So we're going to learn a little bit about Pascal's triangle, how that works in terms of the binomial expansions. We'll learn how to read coefficients and how to find coefficients. We'll look at factorials, and then we'll look at some of the harder cases of binomial expansions, which is the show questions. So looking at that, we'll try to apply it maybe in differentiation. In Year 12, there can be integration. And like I said, we'll leave perms and coms. And we might look at some of these harder binomial theorem questions as well. All right. Let's do it. In here, for extension 2 kids, there are even harder 3-unit problems for you to give a shot at if you're interested. Okay, part 1. Wait, just before I do get started, has anyone, let's say, has anyone actually started this topic, binomial theorem? So who's done it? Nobody? Nobody's on this at school? Ben, haven't you finished it? Haven't you started this?
Yeah, we did. We did it after perms into comps and stuff.
Oh, so yeah.
But it was kind of poorly explained.
Yeah, that's fine. No, I know, but I just want to know who's done it. Like, so you've done it. Anyone else?
I think I did it.
Okay. Yep. And that's it. So 2. I just want to know the speed I should be going at. That's all. All right. Expansion of a plus b to the n. All right. The first thing is, obviously, we know the expansions of this basic one. It's x squared plus 2x plus 1. The expansion of this is x cubed plus 3x squared plus 3x plus 1. The expansion of this is x power 4 plus 4x power 3 plus 6x to the power of 2 plus 4x plus 1. Now, I know that because it's fairly straightforward. The way you're meant to look at these is, now I'm not going to bore you with Pascal's triangle, I'm sure you guys can do it at school. The way we're meant to look at this, the most important things are the coefficients. If we're able to find the coefficients, the trick to it is, obviously those who, again, are in extension 2, this should be fairly straightforward. The trick to it is you start off with the first letter here, squared, there it is, and you keep decreasing this by 1, so x squared becomes x to the 1, and then x to the 1 will become x to the 0. You keep decreasing it by 1 while you increase the other one by 1. Now in this case you can't see that, but I just want to show you again. You start off with your highest power, x cubed, you decrease it by 1, decrease it by 1, and then gone. Start off with your highest power, decrease it by 1, that's a 3, decrease it by 1, that's a 2, decrease it by 1, that's x to the power of 1, and then gone. Anyone not understand what I mean by that decreasing power? Okay, so once you know that it's going to decrease by 1 and the other one will increase by 1, and we'll see that in a second, the hardest thing of these expansions are the coefficients. And the way to find the coefficients, it's fairly straightforward. You start off with the power, and you guys can go and try this in your calculator. Start off with the power 4, and then you press your choose button, which is shift divide. Shift divide. So 4, choose, and then your first one you're going to try is 0. 4 choose 0. That should say 1. Then you'll do 4 choose 1. Then you'll do 4 choose 2, 4 choose 3, and then 4 choose 4. And then you got 1, 4, 6, 4, 1, exactly as we needed. Now, Aya, Andy, you guys are not in that extension 2 class. Does that make sense, what I've just done there? Do you know how to do it? 4 choose 0?
Yeah, so you just point to the calculator, is that it?
Put in the calculator, it should say 4 choose 0, try it out. Make sure you get 1.
Yeah.
Andy, what about you?
So for the middle one, would you do
4 choose 2? Oh, yep. So you'll start with 3 choose 0, 3, choose 1, 3, choose 2, 3, choose 3.
And you stop there.
And then what you should, yeah, you stop because you can't try 3, choose 4. You won't be able to go past 4. I mean, you won't be able to go past 3. Sorry.
Sam, I'm pretty sure we started Pascal's at school,
Good.
but like I don't know, it was
It
weird.
was like it was just a touch up. I don't know.
Yeah.
That's fine. That's fine. So, like I said, I'm not going to go jump into the Pascals too much. Who cares about that? It's more this right now. We need to know the coefficients. So, make sense?
Yeah.
Yeah.
Yes, we know because you need to know if you're able to get the coefficients, then as long as you remember what I said here, which is decreasing powers, and then we're going to increase powers, we should be able to do any number. So let's say these are both all ones. Why do you choose all ones? No, it doesn't matter. What can I do? All right, I'm going to do not 1 for a second. I'll just do a plus b to the power of 6, just to show you. So before I start, I have to go and find the coefficients. So what I'm putting in my calculator is 6, choose 0, 6, choose 1, 6, choose 2. Okay, I'm going to stop that. If you have any issues, let me know. I'm just going to start doing it now. And I'm just going to write the answers here. And it's symmetrical. So once you find your middle point, which is 20, 15, 6, and 1. Again, Andy, Aya, all good with that one?
Yeah.
You understand what I've done there? So then, your first coefficient is 1. Andy, as well, you agree, right? All good?
Yeah.
Yeah, all right. The first coefficient is 1. So you start off with a to the 6. Obviously 1. You ignore it. Plus, your next coefficient is 6. Then you decrease this one by 1. You increase the other one by 1. Plus 15. You decrease it by 1. You increase it by 1. Plus, decrease it by 1. Increase it by 1. Plus 15. Decrease it by 1. Increase it by 1. Plus, decrease it by 1. All right. Any questions from anyone? And what you can see all your powers are always 6. 6, 5 plus 1 is 6, 4 plus 2 is 6, 3 plus 3 is 6, 2 plus 4 is 6, 1 plus 5 is 6, and 6. So it's always got to add up to 6. All right, let's do it for this one. Well, that's an easy one. I'm sure you guys can do that. I'll leave that with you at your own time. I might leave that as well for you. I'll just jump straight into this one. Okay, so if I was to do this, again, I'll have to work out my my coefficients. So that's the first thing you got to do, which is 1, 5, and then it should be 10, and then it should be 10 again, right? So it should be 10 again, and then 5, 1. 5, 1, 5, 10, 10, 5, 1. Let's see if you guys agree with my expansion here. All right, so this is what I personally do. I go 1 to the power of 5, obviously is whatever, I'll just write it for now. 1 to the power of 5. Always pluses for me. Then 5, 1 to the power of 4. Obviously, I don't write that, but we'll just leave it for today. Plus 10, 1 cubed, squared. Plus 10, 1 squared, plus 5, 1, plus 1, and then negative 1 root x to the power of 5. Now I'm going to get rid of all these crap ones that really you should have never written in the first place. But, do we understand that?
Yeah.
100%, right? Yeah? Okay.
Yeah.
Then I'm just going to make it look good, and I think that's it. There's not much more you can do with this. So 1, and then this becomes minus 5 on root x. This is positive, so plus 10 on x, because the root and the squared cancels out. This one's a negative because it's cubed, so negative 10 on root x cubed. plus, again, that's a power of 4. A negative and a power of 4 is a positive, so that's 5 over root x to the power of 4. That's root x times root x, which is x squared. And then minus 1 on root x to the power of 5. Done. There's not much you can do there. Any questions? I can safely tell you if you can do really well in binomial, in this part of binomial, your algebra will be the best it can be. So if you can really master binomial, your algebraic like steps are going to be as good as it's ever going to be. So this is the topic to perfect your algebra. All right. Otherwise, any questions? Nope. Moving on. Okay. So the binomial theorem pretty much says if I've got anything, it's this, which is n k sum of n choose k xk from x0. But that is it. What are you trying to say? N c k a k b n minus k. You're not even saying that. No, I don't know what you meant for the second one. Doesn't matter. You won't need it. All right. So find the coefficient of x cubed. All right. Let's see how these work. So you could do it, expanding, and eventually you'll find the coefficient. So that's not too hard. But I want to show you a different way. So what you can do, you can eventually generalize your expansions. So your expansions of a plus b to the k, and this is the formula that I personally would recommend you guys memorizing and using. A plus b to the k is equal to n choose k, a to the power of, it doesn't really matter, let's just say a to the power of n minus k, and then b to the k. And that's literally what you're doing. You're always going n, sorry, that's n. You're going whatever the power is, choosing whatever number you want, 0, 1, 2, 3, 4, and then technically you're taking away 1 from that, and then you're increasing by 1 from here. So you're actually doing this, I guess. Just so you know, that's a good formula to remember. It will be useful in almost all of binomial. But that's technically what you're doing each term. Now this lets you find at a particular instance. Let's call it that. Right? I'm not going to confuse you with the math jargon just yet. It's just going to allow you to find out any particular instance that you require it to be. So if I go up, just to show it to you guys, n choose k, a, and a is the first term, b is the second term, right? If you think about what I literally just did even here, like let's say this one here, you could say, well, that is n choose k. That is my a to the k, or n minus k, and then that's your b to the k. And you're doing that every single time. So that formula, technically you've already been doing it. It's just a nice way to recognize that you can find at any instance using this formula. Now, again, you could have expanded this using what we just did, but I don't want to do that. I want to do it this way so you guys can get used to it. So let me show you. N choose k, so it's going to be 5 choose. We don't know what k is. We don't know what k is. We know that a, or x in this case, to the power of n, 5 minus k, and then multiplied by negative 2 to the k. So we don't know what k is. Do we all understand what I've written here? Can we see how that relates to my formula that I've just written here? 5, choose k, x to the 5 minus k, and then minus 2 to the k. Do we all understand this line? Yes?
Yeah.
Now that's at any instance, remember that. If I want it specifically at x cubed, so I want this, specifically in front of x cubed, I know that this term needs to equal to this term. In other words, I know that 5 minus k must equal to 3. 5 minus k must equal to 3. And then the coefficients will obviously be the same. So again, 5 minus k equals to 3. I think we can conclude safely that k must equal to 2. Still with me, everyone? Once I've done that, for k equals to 2, I know what the coefficient is, right? The coefficient's 5, choose 2, and then negative 2 to the power of 2. And I can guarantee you that gives you 40. That's the proper way. That's what you really need to know for binomials. What do we reckon? Does that make sense? Let's do another one. Hold on, I'll come back to that. Let's do expansion. All right, yes. Yes, this one. Find the coefficient of x to the 5 in this. All right, let's write the formula out real quick. Wait, before I do this, is there anyone that's actually confused about this? Or you just need more work? I just want to make sure. Confused or just need more questions? Because if it's more questions, that's fine. If it's I'm confused, yeah, okay. So we understand how the mechanics of it is working.
Yeah.
That's important. Because when I sub in, if I sub in 2, where was I? If I sub in k equals to 2 into here, can you see you're going to actually get x, 5 take away 3, 5 take away 2, which is 3.
Mm-hmm.
And then whatever else it's got in front of it would technically be the coefficient of x cubed. So it's a pretty powerful formula. Let's go back. Let's have a look. N ck, an minus k. It doesn't matter. I'll just make a point. If you did a to the k and b to the n minus k, if you did that by accident, no one cares. It's the same formula. So don't think that's a strict formula like that. Doesn't matter. But that's just what I memorized. So what do we know? We know nck is the k plus 1th term. For now, you don't get fancy. nck, a, n minus k, and bk. Okay, same, find the coefficient of x to the 5 here. All right, so for this one here, for the first bracket, let's just do it slowly. I'll say it's n choose k, x to the n, sorry, ugh. X minus 1 is x minus 1, but if you wanted to see the expansion of it, there'll be 1 choose k, because there's a 1 there, and then x to the 1 minus k, and then negative 1 to the k. So again, 1, that's your n. Remember, this is for a plus b to the n. So, Aya, I'm just going to pick on you right now. Do you get that? What I've written there, can you see how that relates to the formula?
Yeah, that makes sense.
100%? You can see how everything works in the formula?
Yeah.
All right, done. Then we'll do the same thing with x plus 1 to the 7. But obviously, to not confuse ourselves, I'm not going to choose k again. We're going to choose r. So it's going to be like 7, choose r, let's say, and then x, 7, take away r. No, I'm wrong. Give me a second. I can see a problem with this. 1 to the r. Let me have a quick think. What did I just do? What did I just do? Should these be the same? Should they be the same? Why did my head say no, but now I'm saying yes, they should be? Give me a second. They shouldn't be. All right, well done. Let me continue it for a second. I'll talk as I'm working it out. Now I know these two are multiplied, so that means these two things need to be multiplied, which means x to the 1 minus k dot x to the 7 minus r must equal to x to the 5. That means 8 minus k minus r must equal to 5. But the problem with that is you don't know what r is. But if I said it was k, this would be 2k minus 2k, and that's definitely wrong. So I know that's wrong. So I'm not wrong with my r. Now I know that. Find the coefficient of x to the 5. Coefficient of x to the 5. What have I forgotten here? I should have revised this real quick. I've never revised. I've always relied on my memory. But I should have revised this one. But I'm still not going to give up. Let's see. All right, let's see what we know. We know 8 take away 5 is 3. 3 equals to k plus r. 3 equals to k plus r. That doesn't help. If 3 equals to k plus r, it's because of this first one. I would have usually not done that. I think so. Because that's just the power of 1. So who does that? Nobody really, because you know the maximum value of k is either going to be 0 or 1. Okay, yeah, that's okay. It's not wrong. It's just that you shouldn't, but then this is the proper way. If you guys had a 3 here, this is the proper way. All right, I'm going to continue. At this step, let's stop here. Again, obviously I can make this easier, but if I show you the easier method, which is me not expanding this into this way, it would work well for this question, but it won't work well for other questions if they were cubed or whatever. So I'm not going to show that. I am going to continue this way, but just tell me, do we understand what I've done so far? So I did x minus 1, I did x plus 1, I am multiplying these two because obviously these two terms are multiplied. And then what I know is that if I'm trying to get x to the 5, that means this x multiplied by this x must equal to x to the 5. And in other words, I am adding the indices here because they're multiplying. That must equal to 5. And then therefore I get this condition. Do we agree with that?
Yeah.
And then there are a few cases. So what you've got to understand, when you've got to this stage, there is the case where r could be... All right, well, let's start with k. K is probably the easier one. K, the maximum value k can be is 1. If k equals to 1, if k equals to 1, r equals to 2. And if k equals to 0, r equals to 3. You can't have any other terms. So if you're going to say, well, Sam, what about r equals to 1? If r equals to 1, therefore you're trying to say k equals to 2, but k can never be 2. Because you can't have 1 choose 2. So do we agree that these are the only two cases? Yes?
Yeah.
Okay. Therefore, when k is 1, you're going to get 1 choose 1. 1 choose 1 minus 1 to the 1 times 7 choose 2 1 to the 2. And what's the answer to that? That should be 7 choose 2 times negative 1 is negative 21. Yes? And then when k is 0, we get 1 choose 0, x to the power, oh, you don't need x because you're only looking at the coefficient, right? Negative 1 to the 0, negative 1 to the 0, times r is 3. 7 choose 3, and then 1 to the 3. No, 7 choose 3, 1 to the 3. Okay, what do we get for that one? That becomes 7 choose 3, which is 35, right? Those are your two cases. And then, of course, because you're trying to, you know, it's like as you expand this, it's the coefficients of x to the 5. So that means it's going to be negative 21 plus 35, which it becomes 14. Who is completely lost now? Well, no, do you guys get it?
Yeah. Pretty,
Andy, you're lost
Makes
completely?
sense.
I just don't know how you got the cases for K and R, the 1 and 2 and 0 and 3.
Okay, that's fair enough. That's fine. I can explain that. That's easy. Do you understand why I'm adding it, actually?
Yeah, that's the bit I don't get why you have to add it.
Well, imagine when I expand this, right? Imagine, just hypothetically, I expanded. Are you just going to get one kind of x squared? Not really. You would assume there to be like 1x squared somewhere, and maybe you're going to get an x, and then eventually somewhere here you might get another, 5x squared. True?
Yeah.
So what are you going to usually do to those coefficients?
Find them.
Oh, and
You're going to add them to simplify your x squared, aren't you?
oh,
Yeah, that's the logic behind adding these two.
and then-
Okay. Now, and Annie, you said I didn't get the cases. The idea with the cases is this is a condition, right? 3 must equal to k plus r. Now you're trying to work out what k and r are. Now you know the maximum k can be is 1. That's it. That's the maximum. So if k is 1, what is r going to be?
Yeah. So yeah.
2. And then when k is 0, what's r going to be?
3.
And that's
Yeah,
it.
that makes
There's no
sense.
other cases. So that means there's not going to be any other coefficients, let's say.
Yeah.
So for x to the 5, you're only going to get these two. Does that make sense?
Yeah.
A way to look at it, if you want to do it, look, if I had to do it faster, if I had this number, just this one here, because it's power of 1, this is x4 in here, multiplied by the x here, would get me x5. And the x5 in here, multiplied by the negative 1, would also get me x5. Can you see how there's going to be two cases?
Yeah.
Good. But the only reason why I don't want to teach that method, it only works because of this question. If I made it just slightly harder, or if I made this even, a 2 or something, yeah, you guys won't be able to get it out. So this is the proper way. Now, I can tell you, I myself had to probably write this down, this exact question, probably 10 times, over and over again until I understood what was happening. Because this is, like I said, if you want to be really good at algebra, binomial. That's all I did. I just kept writing it and writing it until my hands got used to writing this. Otherwise, this is very strange. All right. What about the rest of us that are quiet? Greg, Ben, you've done this. What do you reckon? No, not the same as you. Still hard, isn't it?
No, like I get it. I get how it all works, but just yeah, it's a bit confusing to know when to do stuff. Like,
Yeah, and then
I
that's
get
why
it now. But,
I
yeah.
think I did this. I honestly, it was the only topic where I actually had to write this over and over again because it just wasn't working for me. So I think same as you guys. Like if it wasn't working for me, it's probably not going to work for you guys. You got to just keep writing it until you get used to the mechanics of this.
Mhm.
It's very annoying. Oh, he does have it there, generalized. All right. I'm not going to do these basic ones. I really want to do more of these harder cases. So we'll do that. We'll do this. There we go. Getting good. All right. Let's try it again. So this one's easy because it's just the one expansion. So, all right. Who wants to try this with me? Ben, since you've done it, let's do the first one together. The formula is NCK A N minus K BK. Let's see if that's what he's written. AN minus K. Oh, nice. All right. Let's go. So, what are you going to write?
3NK. Wait, is it? Am I right?
3NK. 3NK. No,
X to the power 3.
4.
Oh.
4. Choose K.
Okay.
Because this equals to, let's just write it, A plus B to the N.
Oh, never mind. Yeah, it's 4.
All good. 4 choose K. And then?
And then it's 3, 4 minus K.
I like to use brackets so we don't make any mistakes. Yep. And then?
And that's times by 2xk.
Beautiful. And then, of course, in this term, you can see you've got a 2 to the K here, don't you? So just be careful, right? You guys got to remember this. Just be careful. And all you're looking for is for this bit here being equal to x cubed.
Okay.
Do you understand that? So then what should your K equal to?
K equals to 1. Is it 1?
Wrong.
Oh, dude.
All right, hold on.
Wait, Sam, which bit has to equal to x cubed?
Yeah, good point. So look, you're trying to find the coefficient of x cubed, right, Aya? This bit. We don't know what it is. Question mark, question mark, question mark. You agree?
Yeah.
We don't know. But what we know, we've got an equation here, or we've got a formula here, or we've got something, however you want to think about it. That looks like there's some stuff, there's some numbers in front of x to the power of any k. That is the same as this question mark.
The whole thing.
Yeah, the whole thing. Now, so what must equal to x cubed? Well, this bit must equal to this bit. The x values must equal to the x values.
K equals 3.
No, k equals to 3.
Yeah.
You see that, Aya?
Yeah.
So when k equals to 3, then if k equals to 3, then you can get your coefficient. 4 choose 3, 3 to the power of 4 minus 3, times by 2 to the power of 3. And then that should give you whatever, 2 to the power of 5 times 3, whatever that is. 2 to the power of 5 times 3, 96. You can just leave it as 96. Do you get that? Without actually expanding it. Yeah, okay. Ben, you fully get it now?
Yeah.
All right. Aya, what about you?
Yeah.
100%. Yeah. Do you see
Yeah.
what's happening with the x to the k and why you're making that equal to x cubed?
Yeah.
Good. Because remember, this allows you to find it anywhere. So if I wanted to obviously find an x squared, what are you going to say, Aya? K equals to? 2.
Wait, can you say that again?
If I wanted to find the coefficient of x squared, and I've got this equation now,
I think k equals to 2.
k equals to 2.
Yeah.
Good. And so on and so on and so on. If this was k minus 5, then you would say k minus 5 equals to 3, which means k equals to 8. Right? Because the powers of your x's must be the same. Yeah, go ahead.
Sam, would you keep it as 96 or would you change it how they put it?
No, 96. Doesn't matter. So you might as well write it as 96. It's probably more conventional for you guys to write it as 96. All right, let's try it again. The others that are not saying anything, I don't, I don't know if you know it or not, but I'm assuming if you're not saying it, that means you do get it. So I'm moving on. Just let me know. Let's try it again. Again. Aya, you want to try it? You want to try the first formula?
Yeah.
Go. What are you going to write?
12.
Choose
K.
A.
Minus X.
Sorry?
With minus X go there?
No. First goes A. A is 2.
Oh, yeah.
2 to the power of what?
To the power of 12 minus K.
Yep. And then?
And then minus X.
To the?
Okay.
K. Now we want this to be equal to X squared. Do you understand that? Now, and we want to find the coefficient of that. So before you do that, can you see how this negative X, is negative X the same as X?
No.
So can I just say, oh yeah, K equals to 2?
No.
No. So hold on. First you fix up the left-hand side. So by fixing up, I mean this. Bang. This is, can't do anything to it, so just leave it. And there's a negative, so you're going to take the negative. Ooh, hold on. Can I take the negative out? Yes. Actually, I can take the negative out. Who can tell me what happened? How do I take a negative out?
Divide
Is that the negative?
Just take out the negative, like that?
And
What's the problem? Why did I say ooh?
then the 2 will become negative.
The 2.
Negative only applies to the X.
Oh, you can't, but they're all multiplied, so technically you can take it outside, Stefan.
You can't do a negative 12 choose K. Does that work?
Say again?
You can't like do a negative choose K thingy. You can't
no,
choose a negative.
No, sorry. That's a negative in front of the whole
Oh.
expression. Whatever number this is, it's a negative.
Oh, okay. Oh, never mind.
Oh, it
Never
doesn't.
mind, never mind.
But I'm saying, why can't I just take out a negative? And I went, ooh. But then I go, oh, no, actually, I can't. So, this is wrong, is what I'm trying to say. You can't just take out a negative. Why? Okay, what if K was 2? What if K was 2? What just happened?
Then X will be positive.
Yeah, then X would be positive, and then how come you took out a negative?
There's no point.
They're not there. It's wrong. So how do I fix that up? This is negative. We get that? So if you're going to take out a negative, you've got to remember that's got a power still. So negative 1 to the K, and then X to the K. Yeah. So when you're factorizing, you can't forget your powers. But then that would solve the problem that we just had. If it's a 1, then that's still negative. If it's a 2, that's positive. If it's a 3, that's negative. 4, positive. That's how you take out a negative. Be careful. And now, obviously, what does K equal to? 2. Now that K equals to 2, your answer is 12, choose 2, 2 to the power of 10, and then negative 1 to the power of 2. Pretty much everything else that has all the numbers that has no x's. That should give you, find x squared term in the expansion. That should give you 12, choose 2, 2 to the power of 10. This does say the term, so you're going to have x squared still, I guess. If it said coefficient, then you're just looking at the number in front. Again, you can leave it like that. You can write the biggest number you want. It's up to you. Let's go again. All right, let's go again. Find the term independent of x. What does that mean? What's another way that we say that? Find the term independent of x.
The constant.
Thank you. Constant. So that means x to the power of what, in other words? If it's a constant, x should be to the power of
1.
nah. X power 1 is x.
0.
0.
0.
Oh,
You're on the roll.
yeah.
Why you say 1?
I
X,
was thinking.
x to the
Thinking out
0.
loud.
X to the 0. X to the 0 is 1, so then that would give you a constant. All right, let's see. N choose K. Do I need to keep writing the formula, or do we know the formula by now? Don't write it? Okay. 6 choose K. X squared. 6 minus K. 1 on X K. All right, and we want it to be x to the 0. All right, that's nothing. We've got to fix this side up. 6 choose K. X 12 minus 2K. Don't leave it like this. You do this x to the power of -1 and then K. Right? Index laws. 6 choose K. X. And then I think we can save me a step. This is -k, and then you're going to simplify your x's. That becomes 12. -2, take away one more. All right, I'll pause there. Aya, does that make sense what I'm doing here? I'm trying to simplify my x's until I get just the one x, so I can say this side must equal to this side,
Yeah.
essentially. It's starting to make more sense, Andy?
Yeah.
Looks good? All right. Then 12 minus 3k must equal to 0, must equal to 1, must equal to 2, whatever you want, right? You guys get it? Like, it doesn't really matter. This method here doesn't really change. It's more about the left-hand side. That's really important. Now, equals to 0. I think I can see k equals to 4. Therefore, the answer is 6, choose 4. Whatever that is. You want to leave it, you want to write 15, it doesn't matter. Usually worth 3 marks in extension 1. And the good news, remember, see, the thing is with advanced, you don't know what you're going to get. You don't know what you're going to get in your test. That's how advanced works. That's how the advanced syllabus works. The good news with extension, every question you learn, so like this, will be tested. It must be tested. So you know you definitely will get a question like this in your exams. It's not like advanced where we learned, you know, let's say in trig, you learned all of sec, cosec, you don't know which one you're going to get. It's not like that. Whatever you learn in extension is tested. That's the good news with the extension syllabus. So one of these will be in your exams. All right, try this. I'll give you guys a few minutes. I might leave it there so you know the formula. Remember, no x squared. Be careful with the 2, and I'll see. Just write a few things down. Okay. Let me see what I've got as my first line. Constant term again. So we know it's going to be x to the 0. All right. So 7, choose k. A n minus k b to the k. Anyone want to give me their next line, what they wrote? Stefan, you want to try? What's your next line?
7 choose K.
7, choose k.
Would you simplify that?
First thing I would do is just split this up as well, because you know it's got to be split up anyways. Because you've got to have your x's and your coefficients on different things. So 2 to the power of what? 2,
X,
2,
wait,
2,
2.
2
Oh,
to
to
the
the power
power
of
of,
7 minus K.
there we go.
And
Then
then
x
X
to the power of, sorry?
negative,
Yep,
negative 2.
negative 2, and then 7 minus k still.
Yeah.
See?
And
And then you know why I like it like this? Because now you can see this is you're going to be your coefficient. This is part of your coefficient, whereas this is part of your x's. All right. And then x to the power of 5k.
Question.
Yes.
Why are we not allowed to do just bring the x squared up and just do 2x minus 2 to the power of minus 2? Are you not
Hold on.
allowed to do that?
Why are we not allowed to bring?
not a 1.
Why are we not allowed to do what? Say it again. 2x minus 2 like this?
Yeah.
Of
Is
course
that-
you are. Oh, hold on. You are. That's fine. And then to the power of 7 minus k?
Yeah.
Yeah, that's
Yeah.
fine. That's what we've got. And then I'm splitting it
Oh
up.
wait, it's the same thing anyway. Oh,
Yeah,
no.
you can't leave it like that. So the next line, what do you got to do? 2 to the 7 minus k, and then x to the negative 14 plus 2k.
Oh, okay. Yeah.
Yeah, you got to split it up because you want your x's only together. So you can group them and then say this is what they got to equal to.
Okay.
You get me?
Yeah.
Numbers, so x is by itself. I mean, that's a rule. You just got to remember that because you want to equate. Equating coefficients. All right. For those who do partial fractions and stuff. All right. Where are we? 7 choose k. 2, 7 minus k. X, negative 14 plus 2k. And then obviously, because this is multiplied, plus 5k. And then eventually, this power here. So negative 14 plus 7k must equal to 0 because you want an x constant term. K must equal to 2. Therefore, the answer is 7 choose 2 multiplied by 2 to the power of 7 take away 2. And as I told you guys, you see, I don't revise this work. This is all through memory. You know, it's not the math I do at all. Obviously, I don't all teach this at uni. So it's purely through the way I studied, which was a whole 10 minutes, you know, Monday, Tuesday, and then stop, Thursday. It's still there. After 12 years, and it's still there. All right. All good. Any questions? Done. Without fully expanding, which is exactly what I just taught you guys before, find the term containing x cubed. All right, let's do it. Oh, even better. Let's do a harder one. Find the coefficient of this. Is that the hardest? Done. That's our last one. Let's do it. Okay. Here we go. So find the coefficient of x squared in this expansion. Let's see if we understand them now. I'm not going to talk as much and see if you guys can keep up. think about these terms that are going to be multiplied, right? That means essentially it's going to look like this, with the exception of this one here. So let's fix this one up. 3 choose r, x, 3 minus r, and then negative 1 to the r, and then x to the power of negative r. Oh, wait, I'll stop there. Any questions about what I've written? All right, let's finish it off. So now we think about them multiplied like we did before. So if they're multiplied, then I understand that x to the 7k minus k with x to the negative k with x to the 3 minus r with x to the negative r must equal to x to the power of what?
2.
Good. And then we get 7 minus 2k, 7 minus 2k because you're adding the powers, plus 3 minus 2r must equal to 2. 7 plus 3 is 10. Take away 2 equals 2. And then bring this, that gets 8 equals 2k plus 2r, which I think means we get k plus r equals to 4 this time. What do we reckon? Andy, does that make sense at this point of time?
Yep.
All right, can you give me my different cases? Now think about 3 here, and you can't get r being 4, so you can never get k being 0. But give me my cases. R equals what? What's your first one you're going to start with?
3.
3. If r equals 3, k equals to 1. What's another one? R equals?
2.
Of course, and then k equals 2. I'll just finish it off now. When r equals to 1, k equals to 3, r equals to 0, k equals to 4. There is no faster way. Hope you guys know this. Okay, because this is super fast already. Think about the expansion of this to the power of 7. Think of the expansion of this to the power of 3. And then think about this as quick as anyone's going to do it. So r equals to 3, k equals to 1. Okay, and that's it. R equals to 3. So sub it into here. So that becomes 3, choose 3, negative 1, 3, times k is 1. 7, choose 1. That's it. R equals 2. 3, choose 2. Negative 1, 2. Times 7, choose 2. 3, choose 1. Negative 1 to the power of, what are we doing? 1. Times 7, choose 3. I think we get the idea. 3, choose 0. Negative 1 to the power of 0 times 7, choose 4. And then add. Do we understand why we add all 4 of these now? Because these are all the coefficients of x to the power of 2. So if you got to simplify it, and that should give you a final answer. Any questions? Or I'll let you copy down what you need, you guys. Can't really go much than that. Greg, does it make sense? Not yet? Make sense?
Yes, that would make sense.
Yeah.
All right, beautiful work. It's a serious topic. It was probably the worst completed topic for the last, I would say, 20 years for extension students, because it does require some serious algebraic skills. Now, the good news is this was part of Year 12, so they only had, I don't know, and this was done usually after the trials because teachers hated it. So it was done after trials. Students usually would have had, I don't know, 6 weeks max to master it before the HSC. You guys get over a year now, right, until your Year 12 exams. So they brought it down so you get a bit more time to master these. They don't get harder. So there's no harder binomial in year 12 or anything like that. Okay. Anyone still copying or
Was
want
the
me
answer
to explain anything? Sorry?
Was the answer minus 14?
Minus 14? Oh, maybe. Yeah. I don't know. So can someone confirm? They got minus 14? Maybe. I can see that that's going to be subtracted with that, and then these two subtracted.
I got
Yeah,
negative.
yeah. Negative 14 as well?
Yeah.
Beautiful. Yep. Stefan, well done. You know how to use a calculator.
Thank you.
Good stuff. All right. Like I said, you guys, look, just copy it, write it down 10 times. It does get pretty repetitive. I think the most important step is right here. Knowing to write this out properly. If you're able to do that and you're able to execute that, the rest of it kind of makes sense. And then you'll wrap your head around the cases, because that also makes sense. You know, because usually when you expand anything, there isn't just one coefficient. There's a few. So the first step's the hardest step, and I've taught you guys now no fractions, index laws, how to bring them in. I showed you how to factorize your -1 out. That's pretty much it. That's as hard as it gets. So hopefully we're able to execute that. All right. Next component, factorials. How are we going for time? Looks good. You guys did binomial in an hour. Not bad. Factorials. Last bit. Okay. So with factorials, you've got n factorial, which is of course n. You start off with your first number and you multiply it by 1 less, and you keep doing that until you get to 3 times 2 times 1. So 5 factorial is 5 times 4 times 3 times 2 times 1. So simplify this without a calculator. The idea is it's 10 times 9 times 8 times 7 factorial over 7 factorial. These two cancel out, and that becomes 720. If I had a question like this, n plus 2 factorial over n minus 1, you always choose the bigger one. So we'll go n plus 2, then you do n plus 1, then you'll do n, then you'll do n minus 1, and then once you realize they're the same, cancel them out, and we're done. Any questions? We've done a bit of this, if you guys remember, I think back in late term 1 or something. Anyways, all good. Okay, properties of binomial coefficients. Ooh, that's a good one. All right, so n choose r is n factorial over r factorial n minus r factorial. That's technically what it's doing. So when you guys were doing 5 choose 2, your calculator really quickly is doing this for you. 5 factorial over 2 factorial, 5 take away 2 factorial. Amazing speed, right? When you think about it. So anyways, that's what it's doing, and it gets the answer out for you. Property of term below, n choose r is also the same as n minus 1 choose r minus 1 plus n minus 1 choose r. Good property. Thing is, you won't necessarily need to come up with this. They will like put this, if they needed you to use this property, this will be part of double I or something like that, or I, before you move on to the last part. So it's a good property to know. It's not something you have to memorize. Any questions about that? No? Okay. Find the value of this. Solve. solve. All right. So n choose 2. Just so you guys know how to read this. I personally don't write my combinations like this, only because I teach so many years now, like primary, high school, university. I do have a tendency of writing 7/2. Obviously, when I was at your age, I used to write 7/2, but now I keep writing them as fractions, so I don't do it anymore. I just write C's. So you could write it like that, or you could write the C. It's up to you. If I had this, I would be writing now n factorial over, what would I be doing? N factorial over 2 factorial, n minus 2 factorial, right? Equals 7 choose 2, take away 6 choose 2. That's something I'll just plug into my calculator. That gives me 6. Any questions at this stage? No, everyone's with me? Okay, let's just write the formula for this out one more time in case you guys are wondering where I got a few things from. Okay, then 2 factorial, I would, you would multiply here. This becomes 12 now. This, you can't have factorials. Let's start fixing it up. So n minus 1, n minus 2 factorial crosses out. You get n squared minus n equals 12. Bring it to the left side. You can't get -3 terms, so therefore n equals to 4. Why don't you guys try this one? Unless there's questions. Is there any questions about example 20? Why don't you try 21? While you guys are trying it, I'll do it as well. Probably where that property comes in handy. Doesn't matter. It's not looking very nice. And then factorial plus 13 factorial is equal to this. One factorial, 34 minus 1 factorial, 34 plus 21. Well, yep. Whoa. Ho, 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 ho. Oh, all right. All right. I thought it wasn't going to be that bad, but who would have thought? So you can see what I said, what I meant by you want to be really good at algebra, master binomial.
Wait, Sam.
Yeah.
Second line.
Yes, this one.
Yeah. What's the second set of brackets say?
Yeah. Sorry. So what I'm doing is obviously you're trying to make your common denominator, right? So I've got m factorial and then 34 take away m and then 34 take away m take away 1 factorial. So I took away 1 from it because that's what you're allowed to do, right? You take away 1 from the previous one. Is that right?
Yeah, I just couldn't read your writing.
No, I know. I'm just saying, does that make sense though?
Yeah.
Plus 34 over, again, m plus 1, and then I took away 1, so I can make these match, m factorial, and then kept this the same. So then from that, I can pretty much see my common denominator. I can see it's m factorial, I can see it's 34 minus m, I can see it's 34 minus m minus 1 factorial, as well as this extra m plus 1. And then I just do my what's missing. All right, wait, I'll let you guys first copy it down if you want to copy it down. I'll try to zoom in a little bit more. If that helps.
Does it matter that in the second line, does it matter that for the sorry,
Wait,
does it matter that the factorial after m plus 1 disappeared?
this one, m plus
Yeah,
1.
like the actual factor, the factorial part that you didn't add that. Does that matter?
Yes. All right, I'll do it again. I'll do it again. First copy, I think first copy it down. I'll do this question again. And I'll tell you my thinking. Because I didn't think it was going to be like this. So just first copy it down and we'll do it.
What did you write when you crossed out the stuff on the
34 factorial. 34 factorial plus 34.34 factorial.
thing above it?
Above it, what I did is I factorized 34 factorial out.
Okay.
And then I've got 1 plus 34. And then what I realized, that becomes 35, so the numerator is actually the same as your numerator here.
Okay.
Again, I'm going to go through it, but yeah, that's what happens. And I'll do it slower. That was just my own working out. I really didn't think it was going to be like this. Copy it, and then I'll do it again slower, and then we'll work through it line by line. All right. Anyone still copying this mess? All right. Let's redo it. You probably start seeing why everyone hated this topic, right? Especially being at the end of Year 12 and you've got to learn this. And it's like, oh, what? So all this other stuff I got to learn and still got to learn this. Let's start. 30, I might do it a little bit differently just because of obviously I'm going to do a few more steps and we'll talk about it. So, but let's see. 35 factorial over 22 factorial, 35 take away 22 factorial must equal to 34 factorial over m factorial 34 take away m factorial plus 34 factorial over m plus 1 factorial 34 minus m minus 1 factorial. Any questions? Now, the next step, what you've got to think about, and it's a really important skill for factorials, what you've got to really know is that if I'm just going to compare these two for a second, m factorial and m plus 1 factorial. Which one am I going to reduce to the other? It's really important to know that. Are you going to move this one to this, or are you going to move this one to this?
You're going to reduce m plus 1 factorial.
Yeah. Everybody else agree? Aya, Mariette, you all agree with that? We're going to not do this one. We're going to go move from m plus 1 factorial to m factorial. Do we agree or not sure?
Yeah.
Yes? What about you, Aya? You agree?
Yeah.
Because the logic is if you've got 5 factorial, and if you've got 4 factorial, then 5 factorial can be written as 5 times 4. So, and then you can, at least they're the same, you can do stuff to it, let's say. So you always reduce the bigger one. That's the logic. So, left-hand side, just keep it as it is. Nothing interesting is happening here. Right-hand side, it's about your common denominators. That's your first thing you've got to do. So, I've got m and m plus 1. I just leave the m because I know I'm going to reduce this. And that's probably when, if you guys were watching, you saw me stop. I came here, I wrote m plus 1 and m factorial. Done. That's been split up. Same thing with these two. I look at them, I go, which one's the larger one? Well, the left one's larger. So what I'm going to do is going to 34 take away m, and then 34 take away m, take away 1 factorial. What do we reckon? That line makes sense?
Yeah.
Your common denominator must have all denominators. If you've been doing your algebraic fractions like the way I've taught you, you should contain all your denominators. So m factorial, m factorial. 34 minus m, 34 minus m. 34 minus m minus 1 factorial, 34 minus m minus 1 factorial, m plus 1, m plus 1. M factorial, already there. 34 minus m, already there. All right. Any questions about that? Then we ask ourselves what's missing. What's missing from 1, 2, and 3 compared to 1, 2, 3, and 4? You're missing a m plus 1 plus 34 factorial. What are you missing from these 3 and these 4 again? 34 minus m. Any questions? Next line. Next line. I would fix up the bottom now. Now that I found my common denominator and I didn't miss any numerators. My bottom, can you see it's m plus 1 times m factorial, which is the same as m plus 1 factorial, and same thing with this. That's the bigger one. So are we okay with me writing that now? Okay, can you see how this m and this m cancels out? 34 factorial m minus 34 factorial m. Gone. Next line. 34 factorial plus 34 times 34 factorial. Factorize your 34 out. That gets me 1 plus 34. And then can you guys pretty much see that's 1 plus 34, which is 35. 35 times 34 factorial is the same as 35 factorial. So all of these cancel out. Do we agree with that? And then you're down to your last line. So, sorry, say it again.
He said that last step again.
Do you agree with the factorizing bit, firstly?
Yeah.
And then 1 plus 34 is?
Oh, just the fuck, never mind.
35, and that becomes 35 times 34 factorial, which is the same as? 35 factorial. So those will cancel out, and then what are you left with? You're pretty much left with 22, 13 must equal to m plus 1, 34 minus m. And the only way that happens is, let's just say, if m plus 1 equals 22, which is when m equals 21, or if, let's say, m plus 1 equals 13, which is still 22, the other one, sorry, 34 minus m equals 13, which is when m equals still 21. What am I doing? Oh, 34 minus m equals 22. Which means m equals 12. Or you could have done it the other way. You could have done m plus 1 equals to 13, and then 34 minus m equals to 13. Doesn't really matter. So as long as m is 21, here you'll get 22, here you'll get 13. If m is 12, here you'll get 13, and here you get 22, pretty much. Do we get that? And you're done. What do we reckon now? Questions? No? No questions? All right. In the expansion, find the ratio of the coefficients. All right, you're just trying to find the ratio, which means you'll find the coefficient of this, find the coefficient of this, and then divide them. So that's not even anything too crazy. In the expansion, the ratio of 3 consecutive coefficients are, find these coefficients. Well, that's a good one. Let's try that. Let me see what else is there. Are we done? All right. I really wanted to do proofs today. I might leave that one for next week, or if you guys want to try it, you can try it and get back to me. The ratios of 3 consecutive coefficients are 6, 14, and 21. Find these coefficients. What I'm going to say is think of this as a total sum. Pretty sure 6 plus 14 plus 21, 41. So 6, no, not really. 6 over 41, 14 over 41. I really want to come back. I'll come back to this one. If I get time, I'll come back to it. I'll rather do a bit of proofs today, and then it looks like it's going to probably take up some time next week as well to do this still. Find the sum of the coefficients. Okay, that's okay. Hold on. This one. That's the one. That. Proof. You know what I might do before we do that? Because you guys are just going to be like, what the? Okay. So look, with this component, it's all about 1 plus x. Now, of course, they can choose anything else. It doesn't have to be 1 plus x. But in general, it's about 1 plus x to the n. So before we do it, let's just come to here and we'll do theory together. So this part of the topic, which is the hardest for students, is the actual substitution of how this all works. And the reason why this bit's hard is because there is no direction of what to do. It's just going to say show. And there is a lot of creativity. So you've just got to pretty much show what's required. And there are some that are pretty common, so pretty common techniques, but then there are some that aren't so common, and you've got to think outside the box. First thing you've got to do is, let's say, part I. Now I'm going to show it to you pretty much how they are in exams. So part I is usually to expand this. So if I had to expand this, you don't know what the power is, so it's going to look something like this, right? N choose 0, and then you're going to multiply it by 1, and then there's none of this. Plus, then you'll have n choose 1, you're going to decrease this 1, you're going to increase this by 1. Plus, n choose 2, then you're going to have x squared, you're going to increase it by 1 more. N choose 3, you're going to increase it by 1 more. You're going to go all the way until n choose n x to the n, until your last power, and that's n choose n. Do we agree with this, or are we completely confused by the way I've written that out? No, that makes sense. So 1 mark, easy. Double I. Double I pretty much says prove or show anyone have an idea? Oh, firstly, before we say an idea, can anyone tell me from what they can see in double I compared to I and what's different? That's a really important skill to get used to. So look at what you're trying to prove. Look at what was given in I, and obviously what's different.
There's no x.
Exactly. So if you had to take that one step further, do you want to take a guess at what happened to the x? Anyone?
X equals 0.
If x equal to 0, what would you end up with on the right hand side here? All these will be nothing, so what do you end up with?
NC 0.
NC 0. That's not what you wanted. So, you want to give it one more shot?
X equals 1 then.
That would make sense. If x equals to 1, what happens? What do you get here on the left-hand side? That's pretty much what we look at, just so you guys know. We usually look at this side here, because that tells you 1 plus 1 is 2. 2 to the n. And then on the right-hand side, you're going to get n choose 0 plus n choose 1 plus n choose 2 plus. Done. Any questions? Let's try. Okay, obviously. Anyone have an idea? What happened this time?
There's a negative in there.
Say that again.
There's a negative in there.
Yes. So what can you be a little bit more clear with that?
Minus something. Power of something.
You got the right idea. Look, so there's definitely negatives now. Right, so you can see if you had to compare n choose 0, it was positive, and then it became a negative, then it became a positive, then it became a negative, then it became a positive, then it became, okay, and then the last one, oh, what happened? Straight away, what can you say x is?
Negative
X
1.
is negative 1, and that's what happens. If it's negative 1, that becomes, the n choose 1's not changing, it's not getting bigger, it's just negative, positive because it's squared, then it's negative because it's cubed, and so on. So let x equal to negative 1, which means 1 minus 1 is 0, so to simplify this, the answer is just 0. Alright, and let's do another one. Simplify. N choose 0 plus 2n choose 1 plus 4n choose 2 plus 8n choose 3 plus dot 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 plus n choose n 2 to the n. What's the answer to that one now? Well, what would you let x equal to?
Squared.
Not squared. Let x equal to 2. Because x gets replaced for the 2. Can you see that? When you hear 2 cubed, where's my little hand? Here. 2 cubed, 2 squared, and that's x is 2, and choose 0 is still there. So the answer is just going to be 3, 1 plus 2, which is 3, 3 to the n. So the answer to this is going to be 3 to the n. See what I mean by there's no direction? You've got to compare what you have in front of you to what you need. And that's a skill that I've hopefully been training you guys by now to get used to that. What do we have? What do I need? How do I get there? What do I have? What do I need? Well, how do I get there? So, all right. And I think that's pretty much it. Look, the other ones you need to know, other than differentiation, is, all right, before I finish off, can someone tell me what the answer to that is? What's n choose 0? Always. 1. What's n choose n?
1.
1.
Also 1. So, I mean, they could trick you guys, because I could do this. I would probably do this. In one of my exams, I know I've done it. So what I do is I give you the exact same here. But what I do, I go prove, let's say 2, I'm going to try to do this as quickly as I can in my head, 2 n minus 1 minus 1 is equal to nc1 plus nc2 plus dot 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 plus nc n minus 1. Now I usually get a lot of students by that. There's not many students that have ever been able to successfully get it out. And the reason being is they think, well, I've never seen this, but what they're not used to is, okay, what do you have? You've always had n choose 0, right? And n choose n. Well, you don't have that. You don't have n choose 0. So what happened to your n choose 0? It probably disappeared to the left-hand side. This is not stopping at n. It's stopping at just 1 before it. So where's your n choose n? It's also probably on the left-hand side. So just to prove this to you guys, this is what you traditionally have, right? You guys have 2 to the n when you let x equal to 1. You've got n choose 0 plus n choose 1, blah, 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 plus n choose n minus 1 plus n choose n. I'll just do it like that so you guys can see that. Then I know these two are 1 and 1. 1 plus 1 is 2. I can bring 2 to the left-hand side. There it is. And then some of you probably already can see the answer. Factorize your 2 out. That becomes, and you're done. So what I'm trying to say with this equation is that what I'm trying to say by showing you guys this is that, look, it doesn't actually change, right? The questions don't change. It's still got to be this. That's the good news. What you have to get used to, what you got to wrap your head around is if you have something that looks different, you've got to just ask yourself, okay, I've got this now. How do I get from this to this? Because whatever I do here in these lines, I mean, I can give you infinite ways of manipulating, this first line up here. You've got to just learn to move away from this first line to whatever line I want you guys to get to. So the variations are almost infinite, but your starting point is always the same. So you got to look at what you've got and then just compare. Oh yeah, there's an NC0. Oh, this doesn't have an NC0, so it's probably gone to the other side. Oh, this one has an NCN. This one doesn't have an NCN. Oh, it's probably gone to the other side. So you got to be careful of little things like that. Now I think we can get back to that booklet. I really needed to show you guys that today. So, like here, prove. There would be a question like that. And what you've got to know is you have to start with 1 plus x to the n. Expand, n choose 1, n choose 0 plus n choose 1x plus. Then you say let x equal to 1. You just proved. You just prove that 2 to the n is the same as n choose 0 plus n choose 1 plus all the way to n choose n. Will 100% be tested? in one way or another. Okay, so you need to know that one. All right, here we go. Who thinks they know the answer by just looking at it now? Let x equal to what this time?
One.
Minus 1, because that's x. Right? If you think about your x to the n, it's going to be attached at the end. And then when you let x equal to 1, 1 minus 1 is going to give you 0. Now when you let x equals to 2, 2 plus 1 is 3. That one. That one. That one, that one, that one, that one. A little bit different. That's what I'm trying to say. It's just a little bit different. But I'd rather see if we can find some HSC questions like this. That's easy. Anything else? Differentiating. Not yet. I don't think you guys are past this bit yet. Alright. We'll stop from this booklet. Let me save that. Send that to you guys. Solutions. Save. I will save this one though for you guys. Alright, there's that. Okay. While I send you all your notes, please start on question 3. First, expand 1 plus x to the n, exactly as I showed you, and then see if you can get A, B, and C out. I'm just going to send you all your stuff here. I'll even send you this one.